Hi everyone. In this video, we will learn how to calculate upper and lower control limits for P chart. We have the data for a bank and the bank is concerned about the number of wrong customer account numbers recorded. Each week, a random sample of 2500 deposits is taken and the number of incorrect account numbers is recorded. You are required to calculate the sample proportion defective upper and lower control values for the data. Using three sigma control limits, you are required to analyze whether the booking process is in control or out of control. Here we have the information about the data. We have in total 12 samples and each sample is 2500 data points. Now for each sample, we have the information of wrong account numbers. For sample 1, there are 15 wrong account numbers recorded, and for sample 12, wrong account numbers were 3. So for 12 samples, we have a total of 147 wrong account numbers. Now in order to calculate P bar, we calculate the total defectives, which is this value 147, and the total number of observations. Since there are 12 samples and each sample consists of 2500 data points, so the total number of observations will be 12 into 2500. We divide 147 by 12 into 2500 and P bar value is 0.049. Then we calculate the sigma P. Sigma P value can be calculated by using this formula, and the value that we have for sigma P is 0.014. Next, we calculate the upper control limit and lower control limit for P chart. The upper control limit formula for the P chart is this. We plug in the values and the value for upper control limit is 0.0091. Next, we plug in the values in lower control limit formula and the value for lower control limit is 0.0007. Note that for Z, we use a value of 3 as per 3 sigma control limit according to the information given in the data. In the next slide, we will plot these values to check whether the process is in statistical control or not. We can calculate the proportion of defects in each sample by dividing the number of defects in a given sample by the sample size. For example, in sample 1, we have 15 wrong account numbers. The sample size is 2500. So we divide 15 by 2500 and the proportion of defects in sample 1 is 0.0060. We can calculate the proportion of defects for all the samples just like this, and then we can plot these values. Here you have on x-axis the number of samples. There are 12 samples and this is the fractional value or the proportional value of the defects. For sample 1, we have the value which is 0.060 and you can see this value here. For the other sample numbers, these are the proportions plotted here on this graph. What we can see from this graph that sample 7 is above the upper control limit, and that means that the process is out of control. And this is how we calculate the upper and lower control limits for attribute control P chart. Thank you for watching and see you in the next video.